The AA-12 first appeared as a concept in Maxwell Atchisson's workshop in the late 1960s, though the formal patent wouldn't be filed until 1972. Atchisson, a Tennessee-based firearms designer with a reputation for unconventional thinking, had spent years examining military feedback from Southeast Asia. Reports consistently mentioned the psychological effectiveness of shotguns in close-quarters situations, but also noted their limitations: slow follow-up shots, punishing recoil, and the impossibility of sustained automatic fire. Traditional shotgun design had evolved around single shots, or at most, semi-automatic operation. The physics seemed insurmountable. A 12-gauge shell generates 3 to 4 times the recoil energy of a standard rifle cartridge. When weapons designers attempted to create automatic versions, they encountered catastrophic wear on components, uncontrollable muzzle rise, and recoil that made accurate sustained fire impossible. Previous attempts at full auto shotguns, the jackhammer, various modified Remington models, experimental military prototypes, had all failed practical trials. Atchisson's insight came from reconsidering what recoil actually meant. Engineers typically treated recoil as a force to be stopped, absorbed, or redirected. Hydraulic buffers, heavy springs, muzzle brakes, and complex gas-operated systems all tried to arrest the rearward energy as quickly as possible. But Atchisson recognized that human perception of recoil wasn't just about total energy, it was about the rate at which that energy transferred to the shooter's body. A force delivered over 1/10 of a second feels dramatically different from the same force delivered over 3/10 of a second. This temporal approach led him to examine straight blowback operation, typically dismissed for shotguns, because the massive bolt weight required would make the weapon impractically heavy. But Atchisson combined blowback with an unusually long bolt travel, nearly double what conventional wisdom suggested, and added a constant recoil system where the bolt remained in motion throughout the firing cycle. The result was counterintuitive. By allowing the mechanism to move more over a longer distance and time period, he could actually reduce the perceived recoil force. The prototype that emerged looked deceptively simple. 8-round magazine protruding below the receiver, boxy profile, minimal external controls. No gas ports to regulate, no complex recoil springs to tune. The elegance was in the invisible mathematics of mass, velocity, and time that Atchisson had encoded into the bolt's travel distance and the resistance provided by the return springs. If stories like this help you see how engineering quietly shaped history, tell us in the comments what surprised you so far, and stay with us for the next chapter. Maxwell Atchisson operated in the firearms design world of the early 1970s with more constraint than freedom. Unlike major manufacturers with extensive testing facilities and military contracts, independent designers like Atchisson relied on patent protection, personal funds, and the hope that their innovations would eventually attract institutional attention. The AA-12 patent filing in 1972 represented years of development conducted without guaranteed return. The pressure Atchisson faced was partly technical but largely economic and reputational. Firearms design is conservative by necessity. Safety depends on reliability, and revolutionary concepts face intense skepticism. Every previous attempt at practical automatic shotguns had reinforced industry consensus that the idea was fundamentally flawed. Atchisson was proposing not just incremental improvement, but a complete reconceptualization of how shotgun mechanisms could function. His background provided both advantage and liability. Atchisson understood firearms intimately, having worked on various military weapons projects, but he lacked the corporate infrastructure to move rapidly from prototype to production. The AA-12 design required precision manufacturing. The bolt tolerances, spring tensions, and chamber dimensions all needed careful execution to achieve the temporal distribution of recoil forces that made the system work. During the 1970s and early 1980s, Atchison demonstrated the weapon to various military and law enforcement agencies, attempting to generate adoption interest. The demonstrations were technically impressive. Observers consistently noted the surprisingly mild recoil and mechanical reliability, but institutional procurement processes moved slowly, especially for unconventional weapons that didn't fit established tactical doctrines. The design faced a circular problem. Without production capital, Atchison couldn't manufacture enough units to conduct the extensive trials required for military adoption. But without institutional interest, securing production capital remained difficult. The AA-12 existed in a liminal space, proven in limited testing, conceptually validated by its successful operation, but unable to achieve the manufacturing scale and field deployment that would demonstrate its practical value. By the late 1980s, Atchison was aging, and the weapon had not achieved the adoption he'd envisioned. The patent represented a solved engineering problem, but not yet a commercial success. This gap between technical achievement and market recognition characterized much of the weapon's early history. The mechanism that worked so elegantly in demonstration remained largely theoretical in terms of actual deployment. Atchison eventually sold the rights to the AA-12 design to Jerry Baber of Military Police Systems, Inc. in the 1980s. The weapon story would continue, but under different hands and with different resources. For Atchison, the pressure had been to prove that the impossible was merely difficult, a goal he achieved technically, even if the broader recognition would come decades later under someone else's direction. The mechanism at the heart of the AA-12 operates through principles so fundamental they appear obvious only in retrospect. The weapon uses straight blowback operation, the simplest firearm operating system. The bolt is held against the chamber face by spring pressure, and when the cartridge fires, the rearward force of the expanding gases pushes both the spent shell and the bolt backward together until the shell ejects and the springs push the bolt forward to chamber the next round. In most firearms, blowback operation works only with relatively low-pressure cartridges, handgun rounds, .22 caliber ammunition, because the bolt must be heavy enough that the chamber pressure drops to safe levels before the bolt moves far enough rearward to extract the shell. For high-pressure rifle or shotgun cartridges, the required bolt weight would make the weapon impractically heavy or would generate violent, uncontrollable recoil. Atchison's solution involved three interconnected design choices. First, he made the bolt assembly substantially heavier than conventional shotgun bolts. Not quite as heavy as pure blowback physics might suggest necessary, but significantly heavier than gas-operated designs. Second, he extended the bolt travel distance to approximately twice what typical shotguns used, meaning the bolt had further to travel before reaching full rearward extension and beginning its return forward. Third, and most crucially, he implemented constant recoil operation. In this system, the bolt begins moving rearward before the projectiles have left the barrel and continues moving throughout the entire firing cycle. The weapon's receiver and barrel assembly recoil into the stock along with the bolt, all moving as a coordinated system rather than having components that remain stationary while others move. This created a temporal redistribution of force. Instead of the full recoil impulse transferring to the shooter as a sharp, instantaneous kick, the energy transferred gradually over the entire period the bolt traveled rearward, paused, and returned forward. The mathematical relationship between force, mass, and time meant that extending the duration of force application reduced peak force proportionally. The springs Atchison selected provided just enough resistance to control the bolt's rearward velocity without stopping it abruptly. The bolt essentially floated backward, under carefully calculated resistance, maintaining the chamber sealed just long enough for pressure to drop to safe levels, then allowing extraction. Return springs then drove the bolt forward with sufficient energy to strip the next round from the magazine and push it into the chamber. The entire cycle, rearward travel, pause, forward return, occurred in approximately 1/5 of a second at the weapon's cyclic rate of 300 rounds per minute. During sustained firing, the bolt was perpetually in motion, creating steady pressure against the shooter's shoulder rather than repetitive impacts. The sensation shooters reported was of continuous, gentle pushing, rather than the staccato pounding characteristic of conventional automatic weapons. Do you think this design choice was inevitable or a risky gamble at the time? Share your view in the comments and pass this story to someone who enjoys understanding how things really work. Testing the AA-12 revealed characteristics that surprised even Atchisson. The weapon's mechanical simplicity, only 6 major moving parts in the original design, meant there were fewer components to fail or require adjustment. Where gas-operated shotguns needed careful tuning to balance gas port size, piston pressure, and spring tension for different ammunition types, the AA-12's blowback system worked across a wide range of loads without modification. Early demonstrations focused on reliability metrics. Atchisson fired the weapon in various environmental conditions, testing whether dirt, moisture, or temperature extremes would compromise function. The extended bolt travel and heavy bolt mass created a system with substantial mechanical momentum. Once the firing cycle began, it tended to complete even if resistance increased from fouling or debris. The recoil management proved even more effective than theoretical calculations suggested. Observers who fired the weapon consistently reported that sustained bursts felt more like firing a full-auto 5.56mm rifle than a shotgun. The constant recoil system distributed force so effectively that muzzle rise remained controllable even during extended firing strings. High-speed photography of the firing cycle showed the weapon's internal components moving with smooth, consistent motion rather than the violent acceleration and deceleration visible in conventional automatic weapons. An unexpected benefit emerged during ammunition testing. The AA-12 could cycle everything from light target loads to heavy magnum shells without adjustment. The temporal distribution of recoil forces meant that variations in chamber pressure simply changed the speed at which the bolt traveled rearward, but the overall cycle remained functional. This ammunition flexibility would later allow the weapon to fire specialized rounds, fléchette projectiles, less lethal rubber rounds, even explosive Frag-12 shells that would have required significant modification to other automatic shotgun designs. Testing also revealed limitations. The weapon's weight, approximately 12 pounds empty, heavier than most military rifles, reflected the heavy bolt assembly required for blowback operation. The 8-round magazine capacity was lower than the drum magazines some experimental shotguns attempted. Though Atchisson prioritized reliability over capacity, the cyclic rate of 300 rounds per minute, while sustainable for controlled bursts, was slower than many military automatic weapons. Refinement during the testing phase focused primarily on materials and manufacturing processes rather than fundamental design changes. The original concept proved sound. The challenge was ensuring consistent production quality. Springs needed precise tension, bolt dimensions required tight tolerances, and chamber finishing had to meet exact specifications for reliable extraction. Years of intermittent testing demonstrated that Atchisson's temporal approach to recoil management was not just theoretically sound, but practically robust. The weapon functioned reliably across environmental conditions, ammunition types, and firing schedules that would have disabled more complex systems. The simplicity that made the design elegant also made it durable. The final curiosity about the AA-12 emerged not from its original configuration, but from what the design enabled decades later, when Military Police Systems, Inc. acquired the rights and refined the weapon in the 2000s. Engineers discovered that Atchisson's temporal recoil distribution created a platform capable of achievements no one had originally envisioned. The refined version could fire continuously underwater, an achievement that seems impossible until one understands the mechanism. Because the weapon uses blowback operation with no gas ports or complex extraction mechanisms, and because the bolt's momentum carries it through the firing cycle once initiated, the AA-12 continued functioning even when water resistance dramatically increased the forces involved. The temporal distribution of recoil, already designed to manage massive forces over extended duration, simply extended slightly further when underwater. High-speed footage showed the bolt moving more slowly, but completing each cycle successfully. This capability revealed something fundamental about Atchisson's design philosophy. He hadn't optimized the weapon for a specific set of conditions. He'd created a mechanical system with sufficient temporal and force margins that it continued operating even under circumstances far beyond original design parameters. The extended bolt travel and constant recoil system provided built-in tolerance for extreme variations in resistance and pressure. The weapon's ability to chamber and fire Frag-12 explosive projectiles, essentially miniature 19mm grenades, demonstrated another unexpected capability. These rounds generated pressures and recoil forces significantly beyond standard 12-gauge ammunition. Yet the AA-12's mechanism absorbed and distributed these forces using the same temporal principles Atchisson had established in 1972. The bolt simply traveled rearward over its full distance, the springs compressed fully, and the cycle completed, no special tuning required. Perhaps most remarkably, extended durability tests conducted in the 2000s showed the refined AA-12 firing tens of thousands of rounds with minimal maintenance and no parts replacement. The simplicity Atchisson had pursued, fewer moving parts, straightforward mechanical motion, created reliability that complex systems couldn't match. Where gas-operated weapons accumulated carbon buildup in ports and pistons, requiring regular cleaning, the AA-12's blowback system self-cleaned through sheer mechanical force. The final curiosity, then, is that Atchisson's 1972 solution to making automatic shotguns controllable accidentally created a platform so mechanically robust, so tolerant of extreme conditions, that it could accomplish tasks no one had imagined needing. The temporal distribution of forces, designed simply to make recoil manageable, turned out to provide margins sufficient for underwater operation, explosive projectiles, and extraordinary durability. The weapon's capabilities exceeded its designer's intentions because the fundamental approach, time rather than force as the critical variable, proved more broadly applicable than anyone anticipated. The AA-12's legacy in firearms design extends beyond its own limited deployment. Atchisson demonstrated that problems the industry considered solved or unsolvable often remained open to reconceptualization. The conventional wisdom that automatic shotguns were impractical wasn't wrong given the approaches previously attempted, but it proved incomplete once someone examined the underlying physics from a different temporal perspective. Modern firearms engineers cite the AA-12 when discussing the relationship between mechanical simplicity and reliability. The weapon became a case study in how reducing component count and mechanical complexity can improve performance rather than limit it. While contemporary military weapons have trended toward modularity and electronic integration, the AA-12 represents an alternative philosophy, solving problems through careful mechanical design that encodes intelligent behavior into physical relationships between mass, springs, and motion. The weapon's influence appears in other shotgun designs that attempted to manage recoil through extended mechanisms rather than brute force absorption. While few designers replicated the exact straight blowback approach, the patent protections and weight requirements presented barriers. The principle of temporal force distribution influenced thinking about automatic shotgun operation. Several modern semi-automatic shotguns employ longer recoil springs and extended bolt travel specifically to achieve softer recoil impulses. Atchison himself never saw widespread military adoption of his design. The weapon remained primarily a specialized tool, used in limited numbers by certain military and law enforcement units for specific applications. But the technical validation of his approach, that a properly designed automatic shotgun could be controllable, reliable and practical, changed what engineers believed possible. The broader lesson concerns how constraints shape innovation. Atchison faced the constraint that shotgun recoil couldn't be eliminated, only redistributed. Rather than fighting against fundamental physics, he asked how those same physical laws could be arranged to achieve different outcomes. The massive forces involved in shotgun operation became, through temporal redistribution, the very mechanism that made automatic fire practical. For weapons engineering more broadly, the AA-12 demonstrated that the frontier of innovation often lies not in new technologies, but in reconsidering how existing principles interact. Blowback operation, spring mechanics, and Newton's laws of motion were all established long before 1972. Atchison's contribution was recognizing a novel arrangement of known elements, an architectural insight rather than a materials or technological breakthrough. The weapon that seemed impossible in the 1960s became practical, then exceptional in its capabilities, simply because someone questioned whether recoil was fundamentally about force or about time. That question, and the mechanical answer Atchison encoded into steel and springs, remains the AA-12's enduring contribution to engineering thought. Not every problem requires new technology. Sometimes it requires asking whether we're measuring the right variable. If you enjoy calm, true stories about how engineering shaped the world, subscribe to the channel, leave a like, and tell us from which country you're watching. Would you like me to translate this into Spanish or Portuguese as well?